Good morning students, welcome back to chemistry class. Today we are going to start a new lesson, that is chapter 4, carbon and its compounds. It is the branch of chemistry deals with the carbon compounds is known as organic chemistry. It is a basic part of organic chemistry. Carbon is the most abundant element in the nature because the number of carbon compounds is larger than that of all other elements put together in nature. That is why there is a branch of chemistry to study about the carbon compounds, that is organic chemistry. Now let us about the carbon compounds. The carbon belongs to group number 4 in the periodic table. The atomic number of carbon is 6, and in the first shell it has 2 electrons. It occupies only 2 electrons, and remaining 4 electrons will be in the second shell. That means the valency of carbon is 4. It is 4 means tetra. It is known as tetra. Tetravalent atom is carbon. Tetra means 4. The carbon has tetravalency. Then to attain stability, carbon needs 4 more electrons in the outermost shell. Then only there will be stability in the case of carbon atom. Then it needs to gain 4 electrons or lose 4 electrons. Then only carbon can attain stability. But in the case of carbon, it does not gain 4 electrons because we know all the atoms there will be equal number of protons and electrons. In the case of carbon, 6 electrons are there. That means there will be the 6 protons also in the carbon atom. If the carbon atom gain 4 electrons, means there will be 10 electrons total. There will be only 6 protons in the nucleus. That means it cannot hold the 6 protons to 10 electrons. That means it cannot gain 4 electrons. Then what will do? It lose 4 electrons. It is also very difficult because by losing electrons it needs more ionization energy. Then by losing electrons or gaining electrons, both are very difficult in the case of carbon atom. Then what will do? Then carbon atom, to attain stability, it shares its electrons with other carbon atom or with any other atoms. By sharing of electrons, there will be form a bond in between carbon atoms or with any other atoms with carbon or any other atoms. These bonds are known as covalent bond. The compounds formed from the covalent bonds are known as covalent compounds. Covalent bonds are formed by the sharing of electrons. In the last class we have studied about ionic compound. It is formed by the transfer of electrons. Here covalent bonds are formed by sharing of electrons. In the case of carbon atom, the bonds are formed are covalent bonds. Okay students, now let us see the formation of types of covalent bonds in different molecules. Okay.
Okay students, now let us see the formation of covalent bond. Let's take one example here. Hydrogen. The symbol of hydrogen is H. Hydrogen is the first member of the periodic table. The atomic number of hydrogen is 1. Then the electronic configuration of hydrogen is 1 because only 1 electron the hydrogen has. Then in the outermost shell of hydrogen has only 1 electron. That means it needs 1 more electron to attain stability. Then hydrogen, we can represent the hydrogen with electron like this. This into represents the electron. Then take 1 more hydrogen. It also has only 1 electron. Then in the formation of covalent bond, it will share the electrons. Then this hydrogen got 2 electrons, 1 and 1, 2 electrons got. Then it is stable now. This also will take 1 more electron from this. Then it is also stable. Here is by sharing of these electrons, here forms a bond in between these 2 elements. Like this one bond. We can represent like this: hydrogen, bond, hydrogen. Here is only one bond, that is single bond. This is the covalent bond because it formed by the sharing of these two electrons. One pair of electrons share, then formed one covalent bond. This covalent bond is known as single covalent bond because only one pair of electron it shares. Okay, did you understand how does the formation of single covalent bond? This is the example. Then we can represent the molecular formula of this is H2 because two hydrogen atoms takes place in this bond formation. Is it clear for you? Okay. Let's see one more example. Here we have taken oxygen. The atomic number of oxygen is 8. Then electronic configuration of oxygen is, let's see, electronic configuration of oxygen. There are 2 electrons. Then in the first shell 2 electrons, in the second shell 6 electrons. The valency of oxygen is 6. That means it needs 2 more electrons to attain stability. And we can represent the oxygen like this: 1, 2, 3, 4, 5, 6. 6 electrons in the outermost shell. Okay. Then the formation of covalent bond takes one more oxygen. Here also, this oxygen also has 6 electrons in the outermost shell, in the valence shell. Then needs 2 more electrons. It takes 2 electrons from this. That we can represent like this. Okay. Now it has 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Now it got already stability. Now you see this one here only 6 electrons. It needs 2 more electrons to attain stability. Then we'll take 2 electrons from this. Then this also stable now. In the outermost shell it has 8 electrons. Then how many electrons they share? You see here 1 electron, here 1 electron, here 1 electron and here 1 electron. That means 2 pairs of electrons they share in the formation of covalent bond. Now we can represent like this: oxygen, 2 pair of 1 pair single bond, 2 pair 1 more bond. We can represent like this. Here we got 2 bonds. That means this is the formation of dicovalent bond. Is it clear for you? This is the formation of double or dicovalent bond. The example is oxygen. Okay, let's take one more example, that is nitrogen. The atomic number of nitrogen is 7. And what is the electronic configuration? The electronic configuration of nitrogen is, in the first shell 2 electrons, then remaining 5 electrons in the second shell. Okay, then it needs how many electrons to attain stability? Needs 3 more electrons. That means we can represent like this: the nitrogen, the valency of nitrogen, valency 5 in the case of nitrogen. Here we can represent like this. These are the 5 electrons of the valence shell in the case of nitrogen. In the formation of covalent bond, we are taking one more nitrogen. Okay. Here 1, 2, 3, 4, 5. In the case of this also same, the 5 electrons in the valence shell. To attain stability it means 8 electrons in the outermost shell means it will take 3 electrons from this. How? Let's see. It will take 3 electrons from this, then it got 8 electrons in the outermost shell. 3, 6 plus 2, 8. It also needs 8 electrons in the outermost shell. It will also take 3 from this. Okay, then both the elements, nitrogen elements, got the stability now. 8 electrons in the outermost shell. Then how many pairs of electrons they share? You see, 1 pair, 2 pair and 3 pairs. That means in the case of nitrogen, the bond formation is 1 pair, 2 pair and 3 pairs. Here 3 covalent bonds are formed in between these 2 nitrogen atoms. This covalent bond is known as triple covalent bond. This is the example of the formation of triple covalent bond. Is it clear? Okay.